students, welcome to Easy BTech, your guide for BTech and beyond. In this session, we are going to talk properties of Laplace transform. Already we have seen some properties in the previous session. Still we have properties that we are going to discuss now. And before going to start our session, all of you subscribe, share the channel. Let's start our session, properties of Laplace transform. So in this session, we are going to see first convolution property. The property, convolution property. Convolution property. First we discuss the statement, then we can do proof, convolution property. So what it is saying is, if x1 of t Laplace transform is x1 of s and ROC is R1 because it is a signal x1, ROC is R1, and x2 of t Laplace transform is x2 of s, x2 of t Laplace transform is x2 of s and its ROC is R2. Then x1 of t convolution x2 of t, x1 of t convolution x2 of t Laplace transform. Convolution and Laplace of this convolution is x1 of s into x2 of s. Multiplication it will become, and ROC of this is R1 intersection R2. So whenever we have two or more ROCs, the final ROC is intersection of all. Let's take proof now. Let's see the proof. The proof we can do using Laplace transform formula only. So Laplace transform of x of t is equal to x of s and is equal to integral minus infinite plus infinite x of t into e to the power minus st dt. This is the Laplace formula we are writing. Then we want Laplace of x1 of t convolution x2 of t. So before going to apply Laplace of x1 of t convolution x2 of t, first see convolution. What is convolution? Then after that we take Laplace transform. So convolution x1 of t convolution x2 of t, it can be written as integral minus infinite plus infinite x1 of tau into x2 of t minus tau d tau. T minus tau d tau. This is the convolution meaning. Now we are going to take Laplace of x1 of t convolution x2 of t. Following or not, step by step. So x1 of t convolution x2 of t. So how to write Laplace of this x1 of t convolution x2 of t? So integral minus infinite plus infinite x1 of t convolution x2 of t into e to the power minus st dt. As like Laplace formula we are writing. So here convolution meaning already available. That meaning I am going to take. Here convolution is there. Its meaning is there. Right? We are going to take that. So is equal to integral minus infinite plus infinite. In the convolution we have convolution integral again minus infinite plus infinite x1 of tau into x2 of t minus tau, x2 of t minus tau d tau, right, e power minus st dt. So this is a convolution substituted. So here we have two integrations, double integration we have. One integration is with respect to tau, another is with respect to t. So what I am going to do, I am going to arrange the terms like tau in tau terms separately and t terms separately. Just I am going to arrange them. So is equal to integral minus infinite plus infinite x1 of tau into now integral minus infinite plus infinite x2 of t minus tau into e to the power minus st dt d tau. So if you observe here, again we have two integrations, but this is integration with respect to t. Again the result is integration with respect to tau. So in this process I am going to take, let this t minus tau is equal to p, and t will become, right, yeah, t will become p plus tau, right, and lower and upper limits, if you see lower limits, upper limits, before going to lower and upper limits, dt will become dp, because tau is a dummy variable which is like constant. Dt is equal to dp, and lower limits, so t lower limit minus infinite minus tau is equal to p, so p is equal to minus infinity, lower limit is same. Similarly upper limit plus infinity minus tau is equal to p, by this p is equal to plus infinite. So all this data we are going to substitute in this integral. Then we can get, so integral minus infinite plus infinite x1 of tau, right, again integral minus infinite plus infinite x2 of p into e to the power minus s t, t is equal to p plus tau, so write p plus tau here, dt is equal to dp and d tau. So here again I have two integrations, one is with respect to p, another integration is with respect to tau. So I am going to write separately these two integrals. So tau integration separate, p integration separate. See how I am writing? So this is equal to integral minus infinite plus infinite, here x1 of tau into e to the power, here tau term is there, e power minus s tau d tau, this is the tau integration, and integral minus infinite plus infinite x2 of p into e to the power minus sp dp, this is the p integration, and these two integrals are like Laplace formulas, Laplace transform formula. So that is why the first integral says that x1 of s into second integral says that x2 of s, that's all. So what is Laplace transform formula here? Convolution property is saying that Laplace transform of x1 of t convolution x2 of t is equal to x1 of s into x2 of s, x1 of s into x2 of s. So this is the property, convolution property. And another property, differentiation in time domain, very important, differentiation in time domain property, differentiation in time domain, very very important, differentiation in time domain. So this property saying that first we write the statement, then we go for proof. Differentiation in time domain. Differentiation in time domain. I will write once again. Differentiation in time domain. In time domain. So first we write the statement. What is the statement is, if x of t Laplace transform is x of s, ROC is R, and differentiation in time domain means d by dt of x of t Laplace transform. D by dt of Laplace transform is s into x of s, ROC same R. Okay. If x of t is a causal, if x of t is causal, what is causal? Causal means, causal signal means x of t is 0 for t less than 0. Then d by dt of x of t, d by dt of x of t Laplace transform is s into x of s minus small x0. x0 means initial value of x of t. This is the property. So first we prove this one. We can prove using inverse Laplace formula. So proof we can do using inverse Laplace formula. What is inverse Laplace formula? Inverse Laplace transform formula. So f inverse of x of s is equal to small x of t is equal to 1 by 2 pi j integral sigma minus j infinity sigma plus j infinity x of s into e to the power st ds. Right? This is the inverse inverse Laplace formula. Then we want d by dt of x of t. So go to the next step. D by dt of x of t. So this is equal to d by dt of the inverse Laplace formula 1 by 2 pi j integral sigma minus j infinite sigma plus j infinite x of s e to the power st ds. So here differentiation is with respect to t and here integration is with respect to s. They are different, not same. So don't think that they are cancelled. So 1 by 2 pi j and integral sigma minus j infinite and sigma plus j infinite x of s same. So d by dt of e power st ds. Right or not? Because a t term is available here, e power st. So differentiation is only for that. Right? I am circling. Differentiation is only here. So is equal to 1 by 2 pi j. So do in differentiation sigma minus j infinite sigma plus j infinite x of s. Here e power st differentiation is s into e power st ds. Now this formula is like inverse for Laplace formula, but inverse Laplace formula only we have x of s, but here s into x of s is available. So this total we can write as Laplace inverse of L inverse of Laplace inverse of s into x of s, s into x of s, and left side we have d by dt of x of t. So inverse Laplace of s into x of s is equal to d by dt of x of t, and we can call like this also. In this way also we can read. What is that? Laplace of d by dt of x of t. Laplace transform of d by dt of x of t will become s into x of s. Suppose if you have double differentiation d square dt square x of t Laplace, it will become s square into x of s. So very important, please follow. Like d power n dt power n x of t. So how many times you are doing differentiation? That many times power in the power. So s power n x of s. So this is d by dt of x of t Laplace transform. Now if x of t is a causal signal, in this special case, consider x of t is causal, or it is a causal signal. Means what is causal signal? X of t value 0 for t less than 0. This is a causal signal. In this case, what is the Laplace of d by dt of x of t? So what statement is saying? In this case, x of t, d by dt of x of t Laplace transform is s into x of s minus small x0. It means initial value of x of t. So initial value is coming into picture. Initial value of x of t. See the proof. This proof we can do using Laplace formula. So what is the Laplace formula? Laplace transform of x of t is equal to, what is the Laplace transform of x of t? X of s and integral minus infinite plus infinite x of t into e to the power minus st dt. E to the power minus st dt. Now we want d by dt of Laplace. So d by dt, Laplace transform of d by dt of x of t, which is equal to integral minus infinite plus infinite. Here in the place of x of t, d by dt of x of t, e power minus st dt. Okay. So here differentiation, d by dt of x of t. So right, and e power minus st. So here we have uv, integral uv we have. So integral uv is equal to u integral v minus integral u dash integral v. So here you can take e power minus st as u and d by dt of x of t is v. So let's do that uv expansion. U means e power minus st, integration of v. So integration and differentiation d by dt cancelled, x of t, right? And one more important point is, here x of t is 0 for t less than 0. That is why, so in the next step we can do uv. First write that causal. So the integral 0 to infinite, not minus infinite to plus infinite, because x of t is 0 for t less than 0. So d by dt of x of t into e to the power minus st dt. Okay. Now uv expansion, this is u, this is v. Now expand it. U means e power minus st. Integration of v, d by dt, and integration cancel. So x of t, and the limits are there, 0 to infinite, minus integral 0 to infinite u dash means e power minus st, differentiation e power minus st into minus s, right? And integral v means x of t, d by dt, and integration cancel, x of t again dt, right? So here substitute the limits. Upper limit e power minus infinite, which is equal to 0, e power minus infinity and x of infinity means final value of x of t. So e power minus infinity is 0, so 0 into that x of t will become 0, minus lower limit e power minus 0 is 1 and x of 0. Here minus into minus plus, and integral 0 to infinite, and yes, you can write outside because not related to t, x of t into e power minus st dt. So this integral is like Laplace formula, which is equal to x of s, Here it is a causal signal, that is why 0 to infinite only limit. For causal signal, x of s is integral 0 to infinity, because minus infinite to 0 it is 0. So x of t into e power minus st dt. So now we have the same integral, right or not? Therefore, what we have, minus x of 0 plus s into x of s. So this we can write as s into x of s minus x of 0. This is the Laplace transform of d by dt of x of t. So here small x of 0 means initial value of x of t. So please remember, in the case of causal, x of t is causal signal, initial value of x of t. Okay. So very important. Another property we can discuss now. Integration in time domain. Integration in time domain. So very important, this property we can do easily. First see the statement. If x of t If x of t Laplace transform is x of s, x of t Laplace transform is x of s. Integration in time domain means integral 0 to t x of tau d tau. This is the integration in time domain. This Laplace will become x of s by s. So we get by s. In case of differentiation into s. Now in case of in case of differentiation into s, in case of integration by s we get, and ROC is same. Here ROC is r. After integration also ROC is r. Let's see the proof, just 2 lines. The proof is easily done. So consider LHS, left hand side. What is LHS? Integral 0 to t x of tau d tau. So this integral we can write as x of t convolution u of t. X of t convolution u of t. This integral we can write. We already discussed it. X of t convolution u of t we can write. Now in the place of integral we can take x of t convolution u of t. So Laplace transform of x of t convolution u of t. So how to write? So convolution in time domain become multiplication in s domain or frequency domain. So Laplace transform of x of t multiplication Laplace transform of u of t. Right or not? So Laplace transform of x of t. How to write Laplace transform of x of t? X of s. And Laplace transform of u of t. What is that? 1 by s. So finally we get x of s by 1 by s. Very simple. But this is the point here. This is a point. X of t convolution u of t equal to integral 0 to t x of tau d tau. So we already seen. We know already it. We know it. So by this we can do x of s by x integration property, time integration property. So thank you students. Thank you. Please watch videos regularly. Thank you all.